Find the equation of the tangent line for g of x equals the square root of 2x plus 2 over 2x minus 1 at the point x equals 1. To find the equation of the tangent line, we need the x and y coordinates of the point. Right now we only have the x coordinate, so the first thing to do is find the corresponding y coordinate by plugging that x coordinate into the function g of x, which is the square root of 2x plus 2 over 2x minus 1. So our corresponding y coordinate will be g of 1, which is the square root of 2 times 1 plus 2 divided by 2 times 1 minus 1. 2 times 1 is 2, plus 2 over 2 minus 1. 2 plus 2 is a 4, 2 minus 1 is a 1, so we have the square root of 4 over 1. Well, 4 over 1 is a 4, and the square root of 4 is a 2. So we have a y coordinate of 2, which means we have the point 1 comma 2. The next thing to do is find the slope of the tangent line. That's the derivative. So we're going to take the derivative of g of x. Well, g of x is actually the square root of a quotient. I'm going to rewrite that square root as a fractional exponent. It's outside of the entire quotient, which means we start with the power rule for our derivative. G prime of x will be, bring the power down, the 1/2, leave the inside alone, subtract 1 from the power, I will call that 2/2, and now we multiply by the derivative of the inside of the power. That's where the quotient rule comes in. It's the derivative of the inside. It's the derivative of all that right there. Derivative of the numerator, which is a 2, times the denominator left alone, 2x minus 1, minus the numerator left alone, 2x plus 2, times the derivative of the denominator, that's a 2, and the entire thing divided by the denominator squared. So g prime of x is 1/2 2x plus 2 over 2x minus 1. 1 minus 2, negative 1/2 power. In the square brackets, I'll distribute this 2 in here. And we have a 4x minus 2. And I'm going to distribute the negative 2 into here. So that'll be a negative 4x and a negative 4 all over 2x minus 1 squared. We can combine like terms in the numerator inside the square brackets, and the 4x's will cancel because one's positive and one's negative. So I have 1/2. The next thing I have is that entire quantity to the negative 1/2. Now, one way to handle that is just reciprocate the whole thing, and you can then call it positive 1/2. We only need to simplify this expression enough to be able to plug in the x coordinate of 1. So we don't have to simplify it as much as needed when you write the derivative function. Generally, you have to simplify that significantly. Here, we just have to take it far enough that we can evaluate it, which is usually a lot less steps than to fully simplify it. In the square brackets, we have a negative 2, negative 4, negative 6 all together over 2x minus 1 quantity squared. I think we're good enough where we can evaluate it at 1. So our slope is going to be g prime of 1, which will be a 1/2 times a 2 times 1 minus 1 over a 2 times 1 plus a 2, and the entire thing to the 1/2 power, which means square root. And then we have a negative 6 over 2 times 1 minus 1, and then that entire thing squared. So we have a 1/2 times Remember that 1/2 power means square root, but inside of there we have a 2 times 1, which is a 2, minus 1. 2 times 1 is a 2, plus 2. And then we have a negative 6 over 2 times 1 is 2, minus 1 squared. So our slope, which is g prime of 1, is going to be 1/2 times 2 minus 1 is 1 over 2 plus 2, which is a 4. And then we have a negative 6 over 2 minus 1, which is 1 squared. We can multiply the first two fractions. 1 times 1 is 1, 2 times 4 is an 8, so 1 over 8. And then we have a negative 6 over 1 squared, which is 1. We can now multiply these fractions. Multiply the numerators, that'll be a negative 6. Multiply the denominators, that'll be an 8. Let's reduce this by a factor of 2. And I'm ending up with a slope of negative 3/4. We have the point, we have the slope. We can now set up the equation of the tangent line using the point slope formula. Y minus the y coordinate, which is a 2, equals the slope, negative 3/4, times x minus the x coordinate. We want to solve for y. We call that the slope-intercept form. We always want to solve for the y here. And that's done by distributing the negative 3/4 in, which will be negative 3/4 x plus 3/4. And now we're going to add the 2 over. So a negative 3/4 x plus a 3/4 plus the 2. We're going to want to add these constants together here. So we need a common denominator. We're going to multiply this 2 by a 4 over 4. So y equals the negative 3/4 x plus 3/4 plus 2 times 4 is an 8 over 4. And now we can add those together to get our final answer. Y equals negative 3/4 x plus 3 plus 8, 11 over 4. There's the equation of the tangent line for that function at that point.